Okay, welcome everyone. It's a pleasure to have everyone here today. And this is Mike from Learning Times. I'm here to provide any tech support that you may require. You can communicate with me in the chat window. And without further delay, we'll go ahead and get things started. And I'd like to pass things off to our host, Robin Bauer-Kilgo. Go ahead, Robin.
Hi, everyone. Welcome again to another Connecting to Collections Care webinar. We're really excited to have everyone here, so I'm going to go ahead and get started so we can start on our topic. As Mike said, my name is Robin Bauer-Kilgo. I am the Community Coordinator for C2C Care. If you have any questions about the program, please feel free to email me at c2cc@culturalheritage.org. We'll be more than happy to answer your questions. And as Mike said, he is our producer. So if you have any tech questions, feel free to contact or talk to him in the chat itself. For those of you who are new to our program, we are Connecting to Collections Care. That is our website, We are an IMLS-funded program administered through FAIC, and we're here to provide free webinar content and then later courses to kind of help people, small and mid-sized institutions with collections care programs. We have a very large archive on our website. If you go to our website and click on Resources and Archives, you'll be able to see all of our past webinars and a lot of really good information you might have on preservation or care or anything else that you might be interested in. We also have a members-only forum you can access. If you enter in discussions, go through there, sign up for an account. We have a monitored discussion area where you can enter in questions, and we have a group of fabulous people who are volunteer monitors who can come in and actually help answer your collections questions. We have an online presence as well. You can find us on Facebook at C2C Community or follow us on Twitter at C2C Care. Here we will go ahead and do announcements, talk about our programming, and do some other fun things that you might be able to find out about. We have a full slate of upcoming webinars. We're pretty excited about these. More information will be found as we get online and as we kind of approach the dates. In June, we have a webinar on collections and advocacy. July 22nd, we have a webinar on textile care. August 26th, care for archaeological collections. September 9th, there's photography basics. So we have a lot of stuff coming up in the next couple months, and we hope you'll be able to join us. These are, like I said, free webinars. So come by the website. Usually sign-ups happen about a month before the actual webinar itself. Once you go in, you can go ahead and click on it, sign up, and you'll receive email indicators. Quick note about our platform. It looks like everyone's doing a great job at using the chat box, so I'll just give you a quick rundown on it. If you enter in the chat, you're going to hit send. It'll go into the chat box. This is also a good spot to put questions in as we go along. As you put a question in, I will track it. So as our presenter's talking, he won't need to really look at that aspect. And we'll have a full Q&A period afterwards. There's also a great section on the left-hand side called links. Feel free to click that. We have different links in there that might be able to help you. We have our webinar evaluation, which we will remind you guys at the end of this webinar. We have the slides from today's presentation, a fabulous list of resources put together by our presenter. And the last thing we have is a thing about the May Day program, which is currently happening through FAIC. This is a program that happens every May. Basically, we ask for everyone to look at emergency response preparedness. Go ahead and you have an entire month to do something at your institution, which I know can be difficult right now due to some of us not having access. But if you do anything, run a tabletop virtually, work on your emergency response plan, do anything, you can enter to win for a Gaylord gift certificate. So if you click on that link, the link is also located in the links box. Talk about what you've done this month to help for emergency preparedness in May Day, and you might be able to win one of 6 Gaylord gift certificates. So I'm going to go ahead and move along and introduce our speaker. Today's topic is fire protection strategies for collections and museums. Our speaker today is Michael Kilby, who's the Associate Director for Fire Protection at the Smithsonian Institution, where he oversees the fire protection and life safety programs for 19 museums and research centers. He is a licensed fire protection engineer with over 30 years of experience safeguarding cultural properties from fire. Without further ado, I'm going to hand the mic over to Michael, and we're going to go ahead and put you in control of your presentation.
Okay, thank you, Robin. Greetings, everyone. Thanks for joining us today. So I have about 60 minutes to share with our fire experience here at the Smithsonian, some of the lessons that we've learned, and hopefully give you some strategies and tools for protecting your own collections and museums. Pictured here on the slide, first slide, are some of our facilities, our various museums and research centers that we have. A lot of them are in Washington, D.C., but we do have others spread across the Western Hemisphere. Right? So, there we go. So the thing about, each year museums and their collections are destroyed by fire, more than any other natural or man-made cause. Unfortunately, we're never lacking in examples of museum fires. In the U.S. alone, there's an average of over 70 museum fires every year. Pictured here are some museum fires, some old, some recent. The Cathedral, which is a Louisiana State Museum, that's pictured on the upper left of the slide. That fire there in 1988. This fire was caused by a welder's torch. They were working on roof gutters. It made the attic on fire. They lost the attic and the entire third floor of the building. Lots of water damage to the lower two floors. Lost a lot of historic artifacts, furniture, several rare maps. At the bottom of the slide is the New Delhi National Museum of Natural History. They had a fire in 2016. Fire actually started on the top floor and worked its way down to the lower floors. A lot of wood partitions, a lot of combustible exhibit materials that fueled the fire spread. No working sprinkler system. They lost thousands of specimens. And then more recently, in 2018, picture in the upper right of the slide is the Museum Nacional in Rio de Janeiro. And we believe that fire was caused by electrical fault on a circuit serving an air conditioning unit. This was Latin America's largest museum and Brazil's most historic cultural building. The entire museum was destroyed by fire. They had 20 million artifacts, and they believe they've lost approximately 90% of their collection. Again, this building, no working sprinkler systems and an inadequate water supply. So, unfortunately, Smithsonian's been no stranger to fire also. Our first fire was back shortly after the institution was created. Our entire institution was housed in one building, the Smithsonian Castle, which is pictured here. We had some workers who they were installing wood stoves in the Great Hall because it was too cold and there was an exhibit opening coming up. They installed the wood stove, attached it to a flue that they assumed went out through the roof. Unfortunately, the flue only went up into the attic. So when they lit the stove, the hot embers came to rest in the combustible construction of the attic. The fire spread through the attic, through the third floor. We lost a lot of important parts of that building, including our Board of Regents room, our lecture hall, our library, our secretary's office. We also lost collections in that fire, too. We had 200 Native American portraits by the famous artist John Nick Stanley, and only 7 of those paintings were saved. We lost a lot of the effects of our founder, James Smithson, as well as a lot of the official institutional papers that belonged to the first secretary. Of course, back then, we didn't have sprinkler systems, we didn't have fire alarm systems, fire detection systems. We just had pretty rudimentary fire protection measures in place. Smoking was prohibited, couldn't carry exposed flames. We maintained night watch in the building. And in terms of fire suppression, all we had were buckets of water stationed around the castle. And We fast forward to 1970. Our Museum of American History was a relatively new building. We had one of the first IBM computers on an exhibit in a third-floor gallery. Back then, we still were not putting sprinklers in our museum, so there was no sprinkler system. And we didn't have smoke detection. I believe we had fire detectors, heat detectors at the time. So it's believed that due to an electrical fault in the exhibit, fire started. There are a lot of combustible materials. We didn't have strict requirements on the combustibility of our exhibit materials back then. So the fire spread through the exhibit. You can see here, picture on the left is what's left after the fire. Pretty much the fire consumed everything in the exhibit hall. The one thing that we did have going for us at the time is that we had some fire-resistant construction, including fire doors. And if you look at the picture on the right, behind the two gentlemen is a set of fire doors. Behind those doors is where the fire started. These doors held the fire in check for about 45 minutes until the fire department could get there and control the fire. So that's what saved the rest of the building, is the set of fire doors. Unfortunately, we did have smoke damage throughout most of the museum, though. So to prevent and fight fires, we have to understand it. And we have to understand how fires start and impact museums. So I like to start by looking at some of the causes and contributing factors of fires in museums. So this information is from the National Fire Protection Association. It's a little bit dated because it's from 2007 to 2011. But this is the latest data that they have. If you look at this, this is for museums all across the United States. I'm not sure how it varies in other countries. But by far, cooking equipment is the leading cause of museum fires, 43%. After that, smoking materials and heating equipment, including things like portable heaters, are each at 14%. Electrical, 8%. Arson, 8%. Spontaneous combustion, that would be like rags soaked with linseed oil that are properly stored, and hot work at 4%. And then if you look at area of origin, I guess that directly correlates with cooking equipment being at 43% and the area of origin being kitchen cooking areas at 36%. So that, by far, that's one of our biggest hazards in museums. It's interesting to see that it also includes outside areas, and I think a lot of times this is kind of forgotten by museum staff to look at outside of the museum. Are they storing a stack of pallets or other combustibles outside the museum? It's an easy target for arson. You want to keep all these things in mind as you're developing fire prevention and fire protection measures. So let's take also look at contributing factors. These are things that once a fire starts, what makes it worse? So certainly lack of fire compartmentation. This is on the right is a picture of the Museum Nacional in Brazil. Fire started in, I think, near the center of the building, but it was able to spread pretty much in all directions to all portions of the building because they lacked any type of fire barriers to keep the fire from spreading. Continuity of combustibles, whether this is combustible construction in your exhibit halls that allow the fire to spread throughout the exhibit hall, or it's crates and other combustibles in your corridors that allow a fire to just continue to spread. Lack of automatic fire suppression, and we'll talk a little bit more about that later. Delayed discovery of fire. One of the things I wanted to point out in the last slide was that I think it's, let me go back one slide, sorry. So one of the things I wanted to point out was that over half of the fires that do occur happen while museums are open during normal operating hours, but only cause 21% of the losses. Conversely, the other half of the fires happen when museums are closed at night, and those fires cause 79% of the property damage. So, this, I think, goes back to museums not having fire detection systems or not having fire detection systems that are continuously monitored so that they can discover a fire early and start firefighting operations right away. So also want to look at other contributing factors, including combustibility of the building and exhibit materials. A lot of museums are historic buildings that were built before there were a lot of restrictions on the type of materials that you use and how combustible they are. I always like to cover museum fire myths. I've been doing this for a while, and I hear a lot of statements, and I think there's definitely some misconceptions out there about fire protection for museums. A lot of people say, well, my building is non-combustible, it's made of concrete and steel. We're not going to have a problem. It's fire safe. Picture here on the slide on the right is the Museum of Modern Art in Rio de Janeiro. They had a fire in 1978, and 90% of their collections were destroyed. The museum is built with, it's all, you can see here, it's all concrete, glass, and steel. And the picture on the bottom right is what's left of the museum after the fire. So the problem is, even though you have non-combustible construction, we fill our museums with combustible finishes, combustible furnishings, so there's still plenty to burn, even in a non-combustible building. Another myth is, we'll be okay, we got a fire department right next door. Well, the fire department's not going to get there as quickly as a sprinkler system can activate. And if you don't have fire smoke detection throughout your museum, then you're definitely going to have a long delay between when the fire starts and when the fire is discovered, especially if the fire happens at nighttime. So by the time the fire department gets there, the fire could have a real foothold and has done a lot of damage to your building and your collections. Some people say, well, we have an extremely good fire prevention program, so we don't need sprinklers or we don't need fire detection. And while fire prevention is extremely important, it can never stop 100% of the fires. So you also want to make sure that you have fire suppression, fire detection, as well as fire separations in place. And lastly, and I'll go into this a little bit more later, is automatic sprinklers are just as damaging as a fire. And if sprinklers are individually activated, they put only a fraction of the amount of water on the fire that a fire department hose would. I always find it interesting when I read some of these news articles about museum fire, and they talk about how much water was dumped on the building by the sprinkler system. But they don't, and they say, oh, well, it was just a small fire. But they don't say that, how much of the museum would have been destroyed if the building didn't have sprinklers in the first place. Oh, okay, so we have a polling question here, right? So our first question is, just like to get everyone's opinion. Are automatic sprinkler systems appropriate for protecting museums? 3 options for answers. If you could please click on your answer. First is yes, always, sometimes, or no, usually not appropriate. Just like to get everyone's opinion. So we'll take a minute and let everybody answer. So I'll give just about 30 seconds for everybody to answer. Okay. Thank you, everybody, for participating in that poll. I'm encouraged to see that most people, not very many people, answered no. And it looks like the majority have answered at least sprinklers are appropriate sometimes. So we're going to revisit this question towards the end after I give some more information about sprinkler systems, just to see if anyone changes their mind here. Okay, so let's and move on. It looks like we're still getting some responses. It looks like we have 61% of the participants are saying sometimes it's appropriate. 36% are saying all the time, and 3% are saying no, never appropriate. Mike, if you don't mind, could we go back to the slide?
Mike will be right back. He's having a couple of technical issues on his side.
Oh, okay.
So give us just 1 second.
All right, everybody have a little more time to think about that polling question.
Well, while we're kind of hanging out on this question, this is Robin again.
Okay.
You know, I wanted to ask a little bit about sprinklers, just because I've heard so many different things about them at different times. About
Sure.
it, like, I know a couple times at institutions I've worked for, we've had to bleed them because, you know, the initial spray that's stuck in them is, to be honest, kind of gross. So would you recommend doing that every once in a while? Or, because I know when we've done it, like we've opened up the sprays, and we've kind of, you know, done that kind of stuff. So I was just curious what, you know, your thoughts were on that.
Yeah, that's certainly a valid question. Sprinkler water is actually very nasty. You know, it has sort of a sulfur smell to it. You know, it's mixing with some of the cutting oils when they thread the pipe. It's kind of a double-edged sword, because the more you flush your sprinkler system, you know, every time you introduce new water into your sprinkler system, you're also introducing oxygen, and then you're promoting corrosion of the interior of the pipe. And what we found is that where we've had to drain down and refill sprinkler systems frequently, we found that the interior of the piping is corroded much more. In some areas in our museums, we've actually installed copper piping instead of steel. The water in the copper tends to stay cleaner. But, you know, one thing to keep in mind is that if you have a fire large enough to activate a sprinkler head, probably your last concern is going to be how clean the water is. Your first objective is just to control the fire. And, you know, only the water that's actually sitting in the sprinkler system is has gotten kind of nasty, but the water coming behind it is from your public water supply, which is clean water.
Interesting. Looking like we're getting slowly back in control right now.
Okay,
Excellent.
yes, so that's my next slide. It doesn't look like I don't have control of it yet. I can talk to this slide. So
okay.
Now that we've talked about the fire problem, contributing factors. Thank you, Mike.
Okay, are you able to advance the slides now?
It doesn't look like I have control yet.
Okay, hold on here.
So while you're working on that, I'll talk to this slide, though. Oh, there, now I do. Thank you, Mike. So let's talk about managing fire risk. So in terms of trying to develop a plan to manage fire risk, you first want to identify what really matters to your museum. I think pretty much everyone's going to agree that life safety is a top priority. Protecting your staff, protecting your visitors. Certainly for us, and probably for most museums, it's going to be protecting your collections, as well as protecting the mission of your museum, making sure that you can stay open, stay operating, and of course protecting your building. So once you identify what really matters to your museum, then you need to get more specific with your objectives. So, what is the maximum acceptable loss that you can tolerate? Can you tolerate losing one wing of your museum? Can you tolerate losing one room of collections? Can you tolerate being shut down for a month, or can you tolerate being shut down for a year? You need to really think hard about it. This is what upper management really needs to think hard about. What's your acceptable losses? And once you nail down your specific objectives, then you can begin to plan and implement measures needed to achieve the required level of protection. When it comes to fire protection, there are basically two broad ways to mitigate risk: fire prevention, and then fire protection, which is lessening the impact of the fire when one does occur. So, for example, your maximum acceptable loss is 10,000 square feet of a collection storage space, and you have collection storage spaces that are much larger than that. Then, one of your measures that you may want to put in place, one of your objectives may be to subdivide your collection storage spaces with fire-rated construction, so that the maximum loss that you have is 10,000 square feet. Or maybe you can only tolerate losing 1 week's worth of records. So then you may want to put in operational procedures where you back up your records at the end of each week. So as I mentioned, life safety, usually that's these are the highest priority when it comes to fire protection. So I'd like to start with looking at life safety. Certainly, you want to work with your local building department and fire department. They understand the codes that apply to your area when it comes to life safety. Everyone should put together a egress plan that identifies egress paths, location of stairwells, where your assembly areas are for staff when there's an emergency, and post these plans to make sure staff are familiar with them. Robin mentioned that May Day is coming up, so these are good activities for May Day. If you don't already have an egress plan, as well as having written emergency procedures. And what do you do in different types of emergencies? Have specific roles for specific individuals. That they know that they're familiar with those roles and practice carrying them out. And then also, you need to think about how do you accommodate people with special needs? People in wheelchairs, people who are hard of hearing, or sight impaired. For example, one of the things that we have in a lot of our museums, we have areas of rescue assistance. So if you're in a wheelchair or if you can't descend a stair for some other reason, we have oversized landings in our stairwells in some of our museums that are protected, so that if you're in a wheelchair, you can get to the stairwell and wait for the fire department to help you evacuate. All right, so I think I went over some of this already. So we want to make sure everyone knows their plan and their responsibilities. We want to practice these evacuation procedures to make sure everyone knows their role and can respond quickly. So fire drills are key. That's a good May Day activity to have a fire drill. Make sure that all staff are participating. We'd like to do drills, unannounced drills, so that it makes it a little bit more realistic. And we don't have people waiting at the lobby because we know a drill is going to happen in 5 minutes. And then it's really important to get together after you have an evacuation drill to assess how things went. People may be in an area of the building where they couldn't hear the fire alarm. That kind of information comes out when you do an after-action meeting. You may find that certain people can't perform the roles that they've been assigned for one reason or another. So it's very good to assess how these drills went afterwards. So just one more aspect of life safety I just want to touch on is special events. Most museums have special events. They're great for raising money and increasing the, it's good PR for museums a lot of times. But they do introduce new hazards into your museum. A lot of times you have higher occupant loads, at least in portions of the museum during a special event. Sometimes you're using an area as a place of assembly that's not normally used as a place of assembly. Egress paths and exits can get blocked. We have a lot of events where we build stages or install bars for a nighttime event. And we have to keep an eye and make sure that we're not installing these directly in front of an exit. A lot of times special events include caterers who are cooking, making sure they're doing that safely, not allowing them to bring propane or other fuel gases into the building, having them either use an actual kitchen or do the cooking outside the museum is a good idea. Regulating open flames. We try to eliminate all candles, use of candles in our museums during special events. We had events in the past where someone's caught their clothes on fire due to a candle. Fortunately now there's these little LED candles that look pretty real. Also decorative materials. During special events, people bring in a lot of banners and drapery. Looking at the combustibility of those materials, a lot of times there's fire-resistant alternatives for those materials. The key is advanced planning and having someone who's looking from a safety point of view at your special event plans. I think I forgot. I'm sorry, I forgot to advance the slide on that. And moving on to strategies for managing fire risk. Just a quick overview. Prevent ignition and then manage the fire impact by ensuring safe egress is available, controlling combustion, limiting fire and smoke spread, using fire barriers. And then safeguarding your collections and records. And we'll go into more details on each of these. So I'd like to think of managing fire risk as a three-legged stool. You need each leg there to make sure the stool can stand. First leg is fire prevention, managing ignition sources and combustibles. Second leg is detection and suppression. And then the third leg is fire containment. and we'll cover each of these in just a few minutes. So let's start with fire prevention. The great thing about fire prevention is most of the things that you can do from a fire prevention standpoint are either low cost or no cost. A lot of it's operational controls. So it includes controlling ignition sources, managing your combustibles, getting rid of debris, storing things carefully, managing your exhibit construction in terms of limiting the combustibility of materials, managing hazardous operations to include construction, temporary construction, often introduces a lot of hazards into your building. Special events, which we just covered, as well as looking at wildland and urban interface. So that's where you have museums in rural areas or next to wooded lots. You want to make sure you have enough of a buffer zone so that there is a wildfire that it doesn't spread to your museum. So let's talk about storage. I don't know about you, but at Smithsonian, storage is always an issue. We never have enough storage space. But you want to make sure that you're storing, especially combustible items, in dedicated rooms and away from other operations and other ignition sources. You want to keep areas clean and free, of debris. Get rid of materials that you no longer need. Try to use non-combustible storage shelving and cabinetry, like wood shelves. And if you're lucky enough that you do have sprinkler protection, then making sure that your storage is not blocking the heads, so that the heads can get water to the fire if one occurs. You want to keep your storage at least 18 inches below the sprinkler heads. So, okay, so that's, I think every museum probably has some flammable liquids in their building, some more than others. NFPA 30 is the combustible and flammable liquids code, and it's a great resource on how to store flammable liquids, how to handle flammable liquids. I recommend that you store flammable liquids in an approved flammable liquids cabinet. These cabinets are constructed so that if you do have a fire outside of the cabinet, it prevents the flammable liquids inside the cabinet from heating to the point where they're going to combust. So what we do is if we have over 10 gallons of flammable liquids, then we make sure they're either in safety cans or in approved cabinets. The cabinets themselves will tell you how much flammable liquid they're designed to hold. And so you want to make sure that you don't exceed that amount. And your local building codes will tell you how much flammable liquids you can have in your building and on each floor of your building. So I would consult with your fire department or your building department on how much you can actually store in your building. And certainly you want to look at where you can reduce the amount of flammable liquids that you are storing. If you have flammable liquids that you aren't using any longer, it's best to get rid of them as quickly as you can. Now, all museums have exhibits, and exhibits are great, but they do, they can be caused with some potential hazards. So, sometimes exhibit designers may not realize that they're obstructing exit paths or exit signs. So you want to be looking at designs to make sure that doesn't happen. Whenever exhibits are being built, you have construction inside your museum, and there's hazards with that, whether it's introduction of more combustibles or hazardous operations like hot work. It's always good to have someone looking at your exhibit designs in terms of the materials being used to make sure that you're using fire retardant or non-combustible materials as much as you can. In electrical installations, you want to make sure that they're being done by qualified electricians. We've had a number of electrical fires here at the Smithsonian in our exhibits in the past, so we try to keep an eye on that. And make sure your exhibits aren't interfering with your sprinklers or obstructing your fire strobes or your tool stations. Okay, so let's look at exhibit fabrication. So here's just some recommended requirements for combustibility of materials used in exhibits. For wall and ceiling materials, we work with our designers to make sure that the flame spray of those materials no higher than 25 for an area that doesn't have sprinklers, or no higher than 75 if it's in a sprinkled area. And make sure that the smoke developed index is no higher than 450. So most materials they're used in construction are fire tested, and they should be able to provide you with this information. Most commercial carpeting meets the minimum fire resistance requirements, but it's still good to check that. I think what we find most challenging is the use of plastics and foams. You can be very creative with foams in exhibit construction. Unfortunately, though, most foams are highly combustible and produce copious amounts of smoke. So we work with our exhibit designers to look for alternatives so they can eliminate the use of foam. Where that's impossible, then there are fire retardant coatings that you can encapsulate foam construction with to reduce the chances of ignition. So just a little bit more information on decorative materials used in exhibits. So you want to make sure, as I said before, that you're not obstructing the use of exits and fire equipment. Get the combustibility test data. Try to avoid plastics and foams. What we found with especially a lot of natural history type exhibits is that natural materials that are incorporated into the exhibit can often be treated with a fire retardant solution to make them fire retardant. Unfortunately, what we found is most synthetic materials like nylons or polyesters, they're not very absorbent. So, soaking them or coating them with a fire retardant solution usually is not effective. Okay, I think we have our second polling question. Mike, if you could put that up for the audience. Let's see if we can get that up there. If not, we can come back to it. So the question was, who reviews your museum exhibit designs to ensure fire safety? Is it the local fire or building department? Do you have a museum safety officer that looks at your exhibit plans? Is it your building manager? Do you have a consultant, architect or engineer looking at it? Or maybe no one's reviewing it from a fire protection standpoint. So we'll see if we can get that question up a little later.
Michael, if you could try, oh, there you go. I was going to say, just try advancing to the next slide. Great.
Oh, I didn't realize. Okay, thank you. All right, so there's the question. If everybody could just take a minute to answer that, it should be interesting to see what people are doing.
Michael, if you just want to go ahead and advance to the next slide, and the poll will move on.
Okay, great. Thanks, Mike. Thanks, everybody, for participating in these poll questions. So moving on, I'd like to talk about fire containment and give you some information about that. So fire containment involves passive fire protection. So that's, using the fire resistance of various building elements to prevent fire spread and make sure that your building stands if there is a fire. So fire rating, what that means is, that's the duration that a building element can withstand fire exposure, and that's normally tabulated in hours. So 1 hour, 2 hour, 3 hour. That's how long building element can stay structurally sound or prevent a fire from spreading past the barrier. So fire barriers can be designed to prevent fire spread as well as the spread of smoke. One thing to keep in mind is that steel is not inherently fire resistant. While it doesn't burn during an intense fire, it gets hot and it's soft. It loses its structural strength. So in a lot of at least more modern buildings, you'll see steel that is actually insulated. As this picture here on the bottom, you can see it's the steel beams that have a fire insulation on them to prevent them from basically slowing the transfer of heat to the steel so that it can last in a fire. So, various building elements can be fire rated, columns, beams, floors, walls, and ceilings. And just as important is to make sure that when you do have a fire barrier, that you're protecting any openings in that fire barrier. If you have a doorway, then you need a fire-rated door in that doorway. Or if you have ductwork that's going through your fire barrier, then you need a damper that's going to automatically close and prevent fire from spreading through that barrier at the duct opening. A little bit more on fire containment. So usually building codes dictate the fire rating for load-bearing and structural elements, as well as floors. Fire and smoke-rated construction is also required for stairwell construction, so that your occupants in the building can escape safely during a fire. So while the codes often mandate fire ratings, as I mentioned, the integrity of these elements are often compromised over time. If you have a building that's 50 or 100 years old, the original fire barriers may have been penetrated by pipes, conduit, or new ductwork, or even new doorways. And you need to go back and make sure that all these openings are protected. And where you have pipes or conduit going through a fire barrier, it's important to make sure that fire stopping has been applied to close up those openings. Or where you have doors and a fire barrier, make sure that the doors themselves are fire rated and that they close and latch properly. Fire barriers can be used to enclose hazardous areas such as the emergency generator room or a flammable liquid storage room. We use fire barriers also to enclose each of our collection storage rooms. We use 2-hour fire-rated walls, floors, and ceilings to enclose these spaces to protect our collections. All right, now I'll talk a little bit more about collection storage rooms a little bit later. So let's talk about fire detection and alarm systems. So, there's a number of different types of fire detectors out there. Heat detectors are probably the simplest and the less prone to nuisance alarms, but they respond much slower to a fire than a smoke detector does. Heat detectors, you'll usually find those in areas that where a smoke detector would not work, say dirty or dusty area. You know, it could be a loading dock, it could be a wood shop area, some place like that. I think at our zoo we use heat detectors in some areas that are very dusty in the animal areas. The most common type of smoke detector is a spot type smoke detector. Down here. And so the spot type detector is over here on the right, bottom right. That's probably the most common type of detector that you see throughout museums and other buildings. They work two different ways. There's ionization detectors and photoelectric. Ionization are better for detecting clean burning fires, while photoelectric are better for detecting dirty, very heavy, dark smoke. Also, the beam detectors, these are usually used in very large open areas like an atrium or a very large gallery, sometimes in warehouses as well, because they basically send an optical beam from a transmitter to a receiver that may be 100, 200 feet away. And when the smoke crosses that optical beam, the receiver picks that up, that's receiving less light, and it puts the detector into alarm. And then air aspirating smoke detectors, that's a little bit more state-of-the-art, I guess. They've been out for 15, 20 years now, though. We're finding, actually, that the air aspirating smoke detectors are working very well for us, both in our collection storage areas and our exhibit galleries. The air aspirating smoke detectors work, they have a network of piping that's up in the ceiling with little holes in the piping, and there's a vacuum pump at a central unit, which is pulling the air back to a central detector, taking samples of air continuously. The nice thing about these systems is that the central detector is incredibly sensitive, so it can pick up smoke before someone may even smell the smoke in the area. So that gives you earlier warning of fire. We also noticed that there's some maintenance advantages to these air sampling detection systems. If you imagine you have a big, large gallery with very high ceilings, with a lot of exhibits and cases down below, you have spot type detectors. That means someone has to get in on a lift with a long pole to get to each one of those spot detectors. This introduces risk to the collection as well as to the staff. With the air sampling detectors, you only have to get to one point at the end of the piping to test the whole system. And the central detector can be outside of the collection storage area or outside of your gallery in a closet somewhere. So the maintenance staff only have to go to one point to do any maintenance on the system. In terms of functions of fire detection and alarm systems, they're there to detect smoke or heat. They incorporate audio and visual fire alarms to notify occupants when there's an emergency. They monitor your sprinkler systems. So if you do have a sprinkler system that activates, you'll know that there's water flow right away. They can close fire dampers, smoke dampers, and shut off fans in the event of a fire. They can release fire doors so that they close automatically if smoke is detected. And you want to make sure that they're monitored 24 hours a day, either at the fire department or a central station, if possible. So that it doesn't do you any good if you have a fire detection system that's not monitored at night. So it goes into alarm at night, but if it's not monitored, then you're not getting the fire department there right away. All right, moving right along to fire suppression systems. So when we talk about fire suppression systems for museums, mostly we're talking about automatic sprinkler systems. That's certainly the most common type of automatic fire suppression system used in museums and most buildings. like to talk about 3 different types of sprinkler systems that you may find in museums. First is a wet pipe sprinkler system, and I'll go into details of each of these. Then you have dry pipe systems and pre-action systems. So we'll talk about each one of these one at a time. But the benefits of sprinkler protection is, they're automatic. You're not waiting for a person to detect a fire, call someone, call the fire department, for the fire department to get there. They're working 24 hours a day, 7 days a week, and they automatically detect the fire and apply water to the fire. Sprinklers are heat activated, so you're going to have heads opening up one at a time. If you have a fire, a single head opens above the fire. In those cases, that one head's going to control the fire. If for some reason that one head is not enough and the fire spreads, then adjacent sprinklers will activate. But that way, you're only putting on as much water as you need to control the fire. As I mentioned before, sprinklers put up a fraction of the volume of water on a fire compared to the fire department. They're very simple systems, fairly low maintenance, and are extremely reliable. All right, so let's look at the 3 systems. So pictured at the top here is the wet pipe sprinkler system. So just as its name implies, all the piping is wet. All the piping is filled with water. So there's no delay in the application of water. Once the head opens, you immediately have water flowing on the fire. These are the simplest of the 3 sprinkler systems we're talking about, have the lowest maintenance, the most reliable. And actually, because the piping is always filled with water, you find that you have the least amount of corrosion in the pipes with wet pipe sprinkler systems. So again, the way the wet pipe sprinkler systems work is that if you have a fire, the head sprinkler directly above the fire is heat activated, usually at about a temperature of 155 to 165 degrees, the head will open. So you have water just flowing out of that one head, being applied to the fire, wetting the fuel. Your sprinkler system is interconnected with your public water supply typically. And when it's designed, you have to make sure you have enough pressure to push the water up through the pipes. Now, sprinkler systems, once the head opens, it stays open. And it's up to the fire department or someone on the museum staff to actually close the valve to stop the water flow. But sprinkler systems, they are installed to strict standards. You want to make sure that they're pressure tested when they're installed. We have about 90% of our museums protected with sprinklers, and very, very few accidents or leaks have occurred. Dry pipe systems, a little bit slightly more complicated. The dry pipe systems, the network of piping interconnected with the sprinklers is filled with air, pressurized air. And there's a valve at the base of the system that holds the water back. When a head opens, when you have a fire and the head opens, the pressurized air escapes, the air pressure drops, and that allows the valve holding the water back to open. The water flows, fills the piping, and flows out of the open sprinkler. It's a little bit more complex valve assembly, and you also need an air compressor to fill the pipe network with pressurized air. So it's a little bit more maintenance, a little bit more complicated. Okay, and then finally, I just want to talk about pre-action sprinkler systems. So, like a dry pipe system, you have air in the piping network, and the water is held back by a pre-action valve at the base of the system. So, the difference between a pre-action system and a dry system is the pre-action system is interconnected with a fire alarm smoke detection system in the area. When the smoke detector activates, it sends a signal to the pre-action valve. Pre-action valve opens, allows the piping network to fill with water. At this point, you still don't have any water flowing out of the sprinklers. But now you have your system charged with water ready to go. As the fire keeps growing, it's already set up the smoke detector. As it keeps growing, now it heats up the sprinkler directly above it. That sprinkler opens, and water flows and controls the fire. So we don't have very many pre-action systems at the Smithsonian. We have a few. This may be a consideration for use maybe in the collection storage area where you have high value, highly vulnerable collections that you want to make sure they don't get wet accidentally. The nice thing about pre-action system is, say someone is in a lift and they shear off a sprinkler. With a wet pipe system or a dry pipe system, when that happens, you're going to get water flowing out of the piping where that head's been sheared off. But with a pre-action system, someone hits the head with a lift or a ladder, and the head gets sheared off, you're not going to get any water flow because you still have the pre-action valve holding the water back, waiting for a signal from the smoke detector. Until that smoke detector is off, the water's going to be held back. The less chance of accidental water discharge with a pre-action system. Okay, so I have seen over the years a lot of misconceptions about sprinklers, so I always like to incorporate some sprinkler myths. Let me see here. So, things I've heard people say in the past is, all sprinklers activate at once. And certainly Hollywood doesn't do us any favors. You see in movies where someone holds a match up to a single sprinkler, the sprinkler pop, and then all the sprinklers in the entire area go off. Well, that's definitely not how it works. System will discharge as much water or more than the fire department. Well, we already covered that. That's definitely not the case, especially since in most fires, sprinklers are controlled by 3 heads or less. Installing a sprinkler system in a historic building is just not compatible with the architecture. Well, definitely it's more challenging to put sprinklers in a historic building. It can be done, and it can be done respectfully with the historic fabric of the building. We've gone back and installed sprinklers throughout our castle, which was built in the 1850s. But it can be done. It just takes more thought and more care in doing it. Last one is sprinklers are ugly. Well, I don't think so, but I'm a fire protection engineer. But I certainly hear that from architects. But when you do it right, and there are heads out there that can be concealed, where when you're looking up at the ceiling, all you see is a flat, round plate. You don't see the entire head. So there are ways to install sprinklers without ruining the aesthetics of a building. All right, so let's just look briefly at some other fire suppression systems that are out there. Water mist systems, I wouldn't say they're popular, but I have seen them used in some museum situations. I think in Europe they may be using these a little bit more than in the U.S. I know the National Gallery of Art here in D.C. has a few water mist systems. The nice thing about water mist is that it puts a lot less water, uses a lot less water to extinguish the fire because it's a very fine mist that's coming out. But these systems have to be custom designed for each space, and they typically use high pressure pumps that require a lot more maintenance, and they're definitely more expensive to install. Clean agent systems. In the old days, we used to use halon systems. Now you have other alternatives like FM200 and Energen, and so these are total flooding systems that you may use maybe in a collection storage room or a like an IT room. These systems work well, and they're very, they're very clean. They don't leave a residue in the collections, but they're very expensive. And the other thing to keep in mind is that they require a very tight space. So if you have a collection storage room, it has to be the walls and the openings have to make sure that they are sealed so that they can contain the gas. The other thing with clean agent systems is that they're a one-shot deal. You have a tank of agent that's released when the smoke detection system goes off. If someone leaves a door open or something else like that happens and you can't maintain the concentration, then your system may not work. So we do have some clean agent systems here in our IT and collection storage rooms, just a handful of them. And where we do put clean agent systems in, we back them up with sprinklers, just because the clean agent systems are a little bit less reliable than sprinkler systems. Wet and dry chemical systems, usually that's what we're talking about, special hazards, maybe in a kitchen hood, that type of thing. Hypoxic air systems, we have one hypoxic air system, and that's where we have a chamber where we actually lower the oxygen level down below 15%. And when you do that, then combustion can't be sustained. But again, that requires an extremely tight compartment, and you really only want to do that where you have, in an unoccupied space. So we have the Star Spangled Banner at Natural History in a hypoxic environment because our collection managers and conservators were adamant that we not put any piping with water over the flag, and they were also concerned with the high velocity gas for clean agent systems actually injuring the flag. So that was a pretty expensive, high maintenance system. All right, so I know in the past we had questions on what's the best type of fire extinguisher used for collections or in museums. So let's just talk about fire extinguishers a little bit. So the type of extinguisher you use, should be based on the type of fires that may happen in that area. The listed here are 5 types of fires. Class A is ordinary combustibles, wood, paper, cardboard, those type of things. Class B fires are flammable liquids. Class C is any type of energized equipment. It could be a computer, it could be an electrical panel, anything like that. Class D is pretty rare. These are combustible metals like magnesium or powdered aluminum. Class K are cooking fires, cooking appliances. Anything that uses vegetable or animal fats, vegetable oil or animal fats. So, the great thing about fire extinguishers is it allows staff to quickly fight a fire. You just have to keep in mind that they're only large enough to control very small fires, like a small trash can fire. So let's, you want to take a look at, all extinguishers are labeled as to the type of fires that they can extinguish. Probably the most common type of extinguisher you see out there are the ABC dry chemical type. The nice thing about these is that they can put out pretty much any type of fire you're going to come across in a museum, except for maybe in a kitchen. Wet chemical, there are wet chemical extinguishers that are specifically made for kitchen fires. Carbon dioxide, the nice thing about carbon dioxide is that it's clean. It's a clean gas, so it doesn't leave a residue, but they're really only rated to use on electrical and flammable liquid fires. Water is only used for Class A fires. You don't want to put water on an electrical fire or on a flammable liquid fire because you're going to spread the flammable liquid, make it worse. There are water mist extinguishers where the water comes out as droplets instead of a continuous stream, and those can be used on ordinary combustibles and electrical fires, actually. And then there's clean agent or halide alternatives. Like the carbon dioxide, the agent comes out as a gas. It's clean. It can be used on A, B, or C-type fires. These extinguishers are, good for collection areas, but they're extremely expensive. So in choosing fire extinguishers for your museums, especially for your collection storage areas, you definitely want to, consider the impact of these agents on your collection materials. Up to recently, there wasn't a whole lot of information on how agents affected different types of materials. So, you want to keep in mind, what's the type of the agent, what type of collection materials do you have? There's been some recent testing done on portable extinguishing agents and their impact on cultural resource materials. Let me pull that up here. So there was a study done, I think it was 2012, I believe. It was sponsored by the Fire Research Foundation, and a lot of the research was done by Hughes Associates and Colonial Williamsburg. I was actually involved in helping establish the testing criteria for this test. So the goals of the assessment were to establish a reproducible test protocol for testing agents and their impact on cultural materials. They gathered data on how the materials respond to the agents and examine the efficacy of cleaning techniques. So there's a lot of good information in this study. If you're a collections manager or a conservator, you probably would be interested in looking at this report. So right here is where you can see the report on the web. Also, it's listed in the resources handout that's being provided to everyone. But just to give you a little detail on what that test was looking at. So these are, I know it's hard to see, but you may be able to look at it later. But so this initial test looked at 13 different cultural resource materials like fur, ivory, different types of metals, things that you commonly find in museum collections. And then it looked at all the different portable extinguishing agents out there, and what their effects were, sort of their immediate effects on the materials, as well as their effects over time. Because we realized that if a small museum has an incident where you have hundreds of artifacts that have been contaminated with a portable extinguishing agent, it could take you weeks, months, even years to get all those items cleaned. We wanted to look at what the long-term effects of these agents were on those various materials. And the conservator for Colonial Williamsburg did a fantastic job on this and took notes on the different cleaning methodologies that she tried and how successful they were. So I think there's a lot of good information in this study. All right, so just want to touch on, in particular, strategies for protecting collections. Mainly, looking at how to protect your collections when they're in storage. So from a fire prevention standpoint, limiting operations and access in your collection storage rooms when having it just dedicated to storage. Also looking at your shelving, how you're storing the collections. Sometimes that can either make them more vulnerable or more protected from a fire. And also looking at fire protection strategies, looking at enclosing fire collection storage rooms with fire-rated construction and the type of detection and suppression that you provide in the spaces. So let's talk about fire prevention first for collection storage spaces. As I mentioned, make sure your collection storage rooms are dedicated for that purpose. Avoid processing, conservation, any type of hazardous operations. You don't want them to be occurring in your collection storage rooms. Advocate for using non-combustible shelving. You can put your collections in closed metal cabinets. Sometimes that's not appropriate, but where you can do that, that's excellent protection from a fire protection standpoint, as well as protection from other things as dust and leaks from overhead piping and so forth. Where we have some collection rooms where everything's in a closed metal cabinet, and that really allows me to sleep at night because the chances of a fire spreading through a room where everything is in closed metal cabinets is almost nil. And then also, some collections actually create their own hazard. Nitrate film is extremely combustible, or fluid collections are extremely combustible. You want to make sure those are stored separately from your other collections. All right, so I actually have another polling question for you.
Yep, just advance to the next slide and the poll will appear.
Okay, got it. Thank you. And the question is, does your museum store packing materials or conduct processing in collection storage rooms? And just full disclosure, I wish we could say never at Smithsonian, but I think I'd have to answer sometimes. It's a real challenge for us to make sure that never happens in collection storage rooms.
Yeah, this is Robin. I just wanted to pop on to say I've worked at many places where we've had to do that. Everything had to be stored together. So don't feel bad, everyone, by clicking on that poll. It's okay to be honest.
I work in a museum that has a lot of resources, but we still find it very challenging to make sure that we're not doing those type of operations in our collection storage rooms.
Yeah, and it's looking like that's what. So. Yeah. You are not alone. So I'll let you get back to your presentation.
I'm very impressed with those who can actually answer never. It looks like the majority are answering sometimes, which that's kind of what I expected. For those who answer often, maybe you can take a look at your operations and see if there's a way to separate some of those operations and place them in other types of spaces. Okay, so this slide here just shows what we're doing at Smithsonian to protect our collection storage spaces. It may not be appropriate for every museum, but it's something to look at and consider. As I mentioned before, we enclose all our collection storage spaces with 2-hour rated construction. So the walls, the floors, the ceilings are all fire rated, built to withstand 2 hours of fire, so that if a fire happens in an adjacent space, that the collection stays safe, and the fire department has a couple hours to control the fire and prevent it from spreading into the collections. We also build these barriers so that they are smoke resistant as well, and that means we're putting in fire smoke dampers where we have ductwork crossing through those barriers that will automatically close if there's a fire smoke event somewhere in the museum. We also limit the size of our collection storage spaces to 30,000 square feet. And, that's a pretty large area, but the reason we do that is that if our active fire suppression fails, if for some reason like our sprinkler system doesn't have water, then our maximum loss would be 30,000 square feet of collections. And that would be a tremendous loss, but and we are looking to reduce that size in the future for very valuable collections. We use early warning smoke detection. A lot of our existing collection storage areas have spot type detectors. But our newer collection storage areas, we're putting in the air aspirating smoke detection so that we get even earlier warning of a fire. And then all our collection storage spaces, we install automatic sprinklers. The majority of them are protected wet pipe sprinklers. We do have pre-action in some areas. And in a handful of areas, as I mentioned before, we do also supplement that with clean agent. But I'd say that's a pretty small fraction of our collection storage spaces are actually protected with clean agent systems. And then, just let's see if I covered everything in this slide already. So, with one thing I wanted to mention about sprinklers is that sprinkler systems work best when the entire building is protected with sprinklers. They're designed to catch a fire when it's small and control it. When you don't have full sprinkler protection throughout your building, you could have a fire start in a unsprinkled area and grow large enough that when it does spread into the sprinkled portion of the building, that the sprinkler system can't control it. So really, full sprinkler protection throughout your building is what works best. And as I mentioned before, if you do put clean agent gaseous systems in, we really want to consider putting sprinklers in as a backup. When you do that, the idea is that the clean agent system will activate first upon smoke detection, and then your sprinklers hopefully won't ever have to activate. But if your clean agent system somehow fails to control the fire, then you have sprinklers as a backup. All right. So just to recap a little bit on goals and objectives, when you're starting out in terms of developing a fire protection plan for your museum and you're evaluating how to manage the risk, you want to first set goals and objectives. Think about what really matters to your museum. It's going to always be protecting people, but then what's next? Protecting collections, protecting the mission. Then come up with specific objectives, as we discussed before. All right, and just like to give you some resources. Certainly, you can start with building and fire codes. There's a lot of information in your building and fire codes, and you can talk to fire protection professionals and architects and engineers about the codes and does your building meet the code. Just one thing to keep in mind is that the building and fire codes, your goal is to provide life safety and firefighter safety. The goal of those codes is not to protect your collections, and they're not written to provide you with continued operations. That is not how they're written. So you start with complying with the codes, but if your risk tolerance and your goals are to protect your collections, protect your mission, then you're probably going to have to do other measures besides just meeting minimum code. Some other resources besides just the general building codes and national fire codes are some more specific codes. NFPA 909, which is the code for the protection of cultural resource properties, at museums, libraries, and places of worship. This is actually a fantastic resource for museums. It covers everything I talked about today and much more. It has a lot of information about emergency planning. It's a very good resource. Also, NFPA 914, which is focused on historic structures. The same committee that writes 909 also writes 914. I'm on that committee. Life Safety Code has a section in it on historic buildings. And so that section, since a lot of museums are in historic buildings, is very useful. All the NFPA codes are available online. Let me advance. I'm sorry I didn't advance to my slide here. So, here's the codes. So all these NFPA codes are actually available online. and are for free access. So you can, and I have these listed in the resource page, resource handout. So they didn't, you used to have to buy each one of these standards, but now they're free to everyone, which is great. All right, so another resource is the Smithsonian has a fire protection and life safety design manual. And basically, all of our design criteria for providing fire protection in our museums, including collection storage guidelines and an exhibit fire protection and life safety guideline. Also has checklists in that manual and specifications for fire systems. So there's a link to it here and also in the resource handout. And as I mentioned, also that study on fire extinguishing agents is on that resource handout. So I hope you get a chance to take a look at those. So just to wrap it up, that's right, we're going to readdress this polling question. I'm sorry. So.
Well, and I was just going to pop on real quick, Michael. It's 3:28. Yeah. So we are totally, we can do the poll real quick. We can hang out for a little bit and do some questions, but I just wanted to give you a heads up on it.
Oh, good. Well, I'm just about to give my last slide, so perfect. So if everybody could answer this question one more time, just to humor me, I'd like to see what everyone's thought is on sprinkler systems now that we've talked about it a little bit more. Oh, that's very encouraging.
I was about to say, I think you've swayed people.
What you're saying is getting through or not. So hopefully so. Looks like it. Okay, well, it looks like we're around 83% say that yes, sprinklers are appropriate for museums. That's certainly my opinion, and I think most fire protection experts would say yes, it is. So that looks great. Okay, so last slide is just wrap things up. So in terms of developing a fire protection plan for your museum, as I mentioned before, you want to start by identifying goals and objectives. Always consider life safety as one of your top priorities. Identify your risk tolerance. What's your maximum acceptable loss. Then identify measures to mitigate risk and achieve your goals, right? I always think it's good to look at fire prevention measures first. Typically, these are low cost or no cost operational measures. And there's almost, no matter how good your organization is, there's probably always more you can do from a fire prevention standpoint to improve things. And then look at fire protection measures. Evaluate fire containment separation needs. A lot of old buildings have masonry walls, very heavy construction that you may have construction that is inherently fire resistant, and maybe all you have to do is go back and add fire-rated doors or close-up penetration to use that as a fire barrier. And then evaluate your fire detection and suppression needs. And then once you've done that and you've written it all down, then develop an implementation plan. So you're going to have short and long-term goals, right? I mean, a lot of your fire prevention measures you can put in place in a matter of weeks or months. But we realize that from a fire containment and fire system standpoint, it may take years before you can put these things, have enough money and wherewithal to get those kind of systems in. We began putting sprinklers in our museums back in the 1980s, and we're at about 95% sprinklered, I think, at this point. So, but it's taken, decades for us to get all our museums protected with sprinklers. So with that, I want to thank everybody for sticking with me, and I hope you enjoyed the presentation, and if you have any questions, I'll try my best to answer them.
Thanks so much. Yeah, it's kind of fascinating to watch this because, you know, right now, obviously, we are very COVID focused, but like I live in Florida, so when we do emergency preparedness, everyone talks a lot about hurricanes. That's all you hear is water events, water events. But I was on a call the other day with some folks over in the UK, and they all were like, fire, fire, fire. So it's really interesting to kind of figure out, you know, what everyone needs to focus on. Well, I'm going to go through a couple of these questions that popped up today. We can probably do about 10 minutes of questions. One of the ones that came up today was, we are told not to use materials that have been treated with fire retardants in exhibition construction and fabrication because of off-gassing from fire retardants. Do you recommend the use of fire retardants on fabrics and finishes in exhibitions, or kind of like what's your thought?
Okay, yeah, that's definitely, I mean, it's a great question, and it's definitely a concern with our conservators and collection managers. I think where we have the greatest concern is the use of fire retardants on materials that are inside of a case or in direct contact with an artifact. And that we definitely avoid. So like when we build really large cases, we mandate that the base of those cases be made with fire retardant or non-combustible materials. But in the vitrine where the artifact is above the case, we don't require fire retardant materials actually in the vitrine, because of off-gassing concerns. And then actually what we've done, we found some materials, or actually our collections people found materials that can peel off the bottom of the case from the vitrine, so that we don't get off-gassing that gets into the interior of the vitrine where the artifacts are. I think it's a material called Marvaseal. Right. It's like a foil-backed film that's applied to the top of the case underneath the vitrine, and it seals off the vitrine from the case below.
Yeah, I've heard of that product before through my conservator friends, so it's good to know it's out there floating around. Well, when you were talking about sprinklers, there were a lot of questions that popped up.
Hey, Robin, I'm having a hard time hearing you.
Oh, sorry. Can you hear me okay?
Okay.
Okay,
it's
sorry
really low. Let me
all right,
okay, I can hear you now.
Perfect. Okay, sorry about that. So when you were talking about sprinklers, there were a lot of questions about those. So one of the questions was, what is the advantage of using dry pipe over wet pipe? And we had some answers in the forum as we went, but I wanted to get your thoughts on it as well.
Okay, well, typically you're not going to use dry pipe in a conditioned museum environment. You probably would use pre-action or wet pipe, I would say. And, you know, pre-action is sort of similar to a dry pipe system. So I'll look at it that way in terms of answering it that way. The advantage of wet pipe would be that it's just a more reliable and simpler system from a maintenance standpoint. Back in the 80s, when we were installing our first sprinkler systems in our museums, we started installing pre-action systems, quite a few pre-action systems. And what we found was that our maintenance program wasn't robust enough to keep up with the maintenance. And we would have a lot of false trips where the air pressure wasn't maintained in the system, and or you'd have a detector go into alarm for some reason besides a fire, and then you have the entire piping network filling with water. You get a water flow alarm, so then you evacuate the building. So these nuisance trips of the pre-action systems became a real problem. But what we found were, after we had sprinkler systems in our museums for a few years, and the museum staff became more comfortable with the concept of sprinklers, we were able to go back and convert these pre-action systems over to wet pipe systems. which required less maintenance and less nuisance alarms and nuisance trips where we had to go back and drain the systems and that type of thing.
Excellent. A couple people had also mentioned that it might deal with your building is heated or unheated for cold weather versus dry pipe,
definitely.
wet pipe. So
I
was like, that's a super good point as well.
Oh yeah, absolutely. If it's not heated, certainly like a loading dock area or some other covered exterior space, they're probably going to have to use dry pipe system. We have at our zoo, National Zoo, we certainly have a lot of buildings, animal buildings that aren't heated, and there we have to use dry pipe systems.
That makes sense. So I think the last question I'm going to tackle today is this one, which I find fascinating because I have traditionally worked for history museums. So anytime we deal with natural history, I get very fascinated. So it says, in the past, collections managers for fluid preserved specimens have claimed that low percent alcohols, and they said example, 60% ethanol, is not really flammable. So code compliance is not needed. What are your thoughts on that?
Yeah, I think not me, but one of the other fire protection engineers at Smithsonian, one of my predecessors, said that he had to go out into the parking lot of natural history with a cup of alcohol with the scientists because he was claiming that it wasn't flammable. And so they went out in the parking lot and actually burned it.
Oh my God.
To prove the point. But yeah, ethanol, most natural history specimens are preserved in ethanol, and usually it's kept at a concentration of 70% ethanol. The ethanol is definitely flammable, and it's flammable down to concentrations of about 20%. So, it definitely can burn, and it definitely requires special sprinkler systems, much more robust sprinkler systems to protect fluid collections.
Yeah, that makes sense. And like I've always said, that's always been fascinating to me because I haven't really had to deal with that. So thanks for answering that question.
We have a lot of fluid collections here at Smithsonian.
Yeah, I have friends who've worked for them. Like I said, I'm in Florida, so I know the Florida Museum of Natural History. They have that kind of situation. But like I said, I've never personally had that. So thanks for asking, or answering rather.
Yeah, great question.
I'm going to go ahead and wrap it up today. I want to give a huge thank you to you, Michael, for taking some time today to cover this topic, especially during May Day, which is so important to all of us. Like I said, there's the links on the side, which will go ahead and give you our evaluation, the slides, resources, and that link to the May Day program. A reminder, you can get a Gaylord gift certificate. That's pretty exciting if you fill that out. And Michael, do you have any last words to say today or anything else?
No, I just appreciate everyone's participation. I was amazed at how many people had signed up, and from all over, the U.S. and outside the U.S. So thank you all for participating. And my email is on the slides. If you have a question for me, then feel free to send me a question.
Excellent. So thanks again. Come join us again in June when we have our next live webinar, and hope everyone stays safe and healthy. Thanks again.
Thank you.